Hello and welcome back. It's puzzle time with Sudoku Sleuth. And, before I even say the title, Schrödinger Equation, goodness me, what is Sleuth up to? Now, I'm sure many of you are familiar with Schrödinger's kind of thought experiment of, if you have a cat in a box where there is poison, and potentially the cat can either die from the poison or not die from the poison, that the cat is simultaneously alive and dead until you actually measure it. All about trying to explain the wonderful world of quantum mechanics. But I'm a little bit worried about Sleuth here. I imagine if you're a detective, you end up seeing a lot of grisly human behavior, but he's almost savoring it with that kind of very weird smile. And I definitely don't, recommend anybody trying to stick a cat, well, it looks like even a kitten, into some sort of poisonous flask. Don't do that. Anyway, let's take a look at today's puzzle and rule sets, and you'll understand why this is all about Schrödinger's equation. And if you're not familiar with it, it's essentially kind of Hamilton wave function equal to, which I guess is done in probably German whisper lines. We'll take a look at that in a second, and then it's equal to the energy and wave function. I did try and study quantum physics and mechanics in a course in my university, and I immediately dropped it. I think like 2 or 3 lectures in, I'm done. This is maths that maybe if I really tried really hard to wrap my mind around it, I'll understand. But, who's got the time for that? Clearly, quantum physicists. Anyway, Schrödinger Equation by Tobias Brixner. And we've got the following set of rules. So normal Sudoku rules apply. So place the digits 1 to 9 once each in every row, in every column, and in every 3x3 box. Fairly standard. Then we have, in a cage, numbers add up to the clue in the corner, and no numbers appear more than once. So what that's saying is that, because some of the cages are not necessarily confined to the same column, row, and box. So if this cell here is a 2, this would have to be a 6 to make sure that these 2 cells add up to 8. These 2 are 15. These 3 have to add up to 6. And most importantly, you cannot repeat a digit. You can't have, for example, 7, 7, and a 2, because these 2 7s are inside the same cage, even though they do add up the triplet to 16. So that's cages. Then we have, on a green line, adjacent numbers differ by 5 or more. So essentially, if this was a 2 on this cell, the 2 adjacent digits on the line, would have to be 7, 8, or 9 to be 5 or more away. If you imagine that this cell here is an 8, this would have to be 1 or 3 to be 5 or more away. I mean, it could obviously be a 2, but that would repeat it in the same row and box. And you end up with this pattern of highs 6, 7, 8, or 9, lows 1, 2, 3, or 4. No 5s on this equal sign today, or on the German whisper line. Lastly but not least, the red and blue shading is for aesthetic purposes to make the Schrödinger equation more visible. So the fact that this is red and that this is blue has no semblance on it. Okay, no impact. So, only thing left to say is, it is Schrödinger equation. There are no Schrödinger cells. There should be a unique solution. It'd be very ironic if Tobias actually gave us a non-unique puzzle, though. If you want to play along, link will be in the description down below for you to do so as usual. And with that said, I'm going to restart the clock, see how I get on. So there's some easy cages like this one. This is 1, 2, 3. That's forced. But there are no other easy cages, which tells me that the break-in is different. Right, the break-in is in a few different ways. We can definitely place a digit, 2 digits, maybe more. I mean, clearly we're going to place 81 digits, but we can place one almost immediately. 7, 13, that's 20. That's 20, and 15 is 35, and an 8 is 43. That's a 2. And Sleuth and you may be asking, Sleuth, how did you get this? Remember, Sudoku rules means you have to place the digits 1 to 9 in every column. So if you add up the digits 1 to 9, you're going to add up to 45. And essentially, these cages are showing you 43 of the 45. So this cell here has to get you to 45 with a 2. You can do a similar trick in here with 12 and 13 gives you 25 plus the 19. I think that's a 1. Did I do the math correctly there? Essentially, it's 25 plus 20, which would be 45, minus the 1 for the 19, which is in here. Right, okay. Can do even better. Now that the 2 is on here, we know that these digits are low, because remember, it oscillates between low and high. These cells are high. I use red for high, blue for low. And a 15 cage also would allow us to color this German whisper line. A 15 in 2 cells can only be done in one of 2 ways. It's either 6-9 or 7-8. Whichever one this is, it is clearly a high digit. So that gives me all of these as high, all of these as low. I'm just having a quick look around to see, before I sort of get stuck into the German whisper line, if there's any more kind of Sudoku magic we can use. And I'm thinking yes. So box 1, that's 19 and 20. That is 39. That leaves us with 6. So that's either 1, 5 or 2, 4. Don't know yet. 13 and 13 is 26 plus the 8 is 34, leaving us 11. Right, that is kind of useful because you can see that the 1 can't be in a 13 cage. Otherwise, you'd have to join it with a 12. The 1 can't be in an 11 remainder in 2 cells because it would have to be joined with a 10. And the 1 is not in a 13 cage because we already placed the 1. So that's 1, 7. It's probably easier things for me to go after. I am going to just write this in before I forget it. Then there's definitely really nothing else that's jumping out at me. So kind of tempted to pass. I mean, I know 1s are not in here. So this is either 1, 6 or 1, 7. But it doesn't sound particularly useful, if I'm honest. Yeah, I'm going to move on. Right, German whisper lines. And this cannot be a 4. That would require a double 9. This is 1 or 3. In fact, they are, it is a 1, because essentially these are all 1, 2, 3s, all these 3 cells, because they all have 2 digits that are adjacent, and therefore 4 is off the table, otherwise would require a double 9 to be 5 or more away. However, this 1 tells me these are not 1s. That's a 2, 3 pair. That's got to be a 1. If I can type. Hello. So that's 2, 3. That's the 1. Now, between here, there's a 3 on either side, on one of them. So that's 8 or 9. This is at least a 7 because we've got a 2 in here. So that is 7, 8 or 9. That has to be at least a 3. In fact, it's exactly 3 because a 4, which is the only remaining low digit, given it's not 1 or 2, requires a second 4 in the 8 cage. So that's 3, that's 5. That makes these not 1, 5. That's a 2, 4. Doesn't actually help me with my 1, 7 at the bottom. This is, again, 8, 9 to be next to the 3. That's an 8, 9 pair. That gives me a 7. And these 2 cells, given this is at least a 2, that would make this at least 7, 8, or 9. 7, 8, 9 in the 15 cage would be joined with 6, 7, or 8. Essentially, the 9 would be joined with a 6, and the 7, 8 would be their own pairs. Can I do better? Yeah, this is 4, 5, 6. So what about this 12 cage? Are there any useful deductions here? So, I mean, inside the 12 cage, it's either a 5, 7 or a 3, 9, which is not. It's a 4, 8 cage. And this 4, 5, 6 tells me the order. That's 8, that's 4. That is not an 8 anymore. 2, which you can see here, is not in these two cells. That's a 2. So essentially there's a 7, 9, and a 6. And the 4, 5, 6 hits again. That's a 6. That's a 7, 9. 2s are lining up. There's a 2 inside the 13 cage with an 11 remainder. And it's not 2, 9. It's not 3, 8. It's not 4, 7. It is, in fact, 5, 6. That leaves me with 3 cells that should add up to 19. Hopefully add up to 19. Don't seem to add up to 19. What did I do wrong? Because it says 3, 7, 9. Come again? Did I just, from the start, do this wrong with this one? Sorry, I'm having a moment here. The 2s do line up, and it forces the 2 in here, and it leaves 5 and 6. And this is indeed the remainder. Yes, it does add up to 19. 3, 7, 9. Sleuth. Right, I'm going to bed after this. I woke up early, and I thought I may as well do some recording. If I'm struggling to add up 3, 7, and 9 to 19, you know you need a break. Let's see, what else do I have left? So these 13 cages, it's not 6, 7. It's not 5, 8. It is 4, 9. That 4 gives me an order. That's 4. That's 9. That gives me 7. That gives me 1 and 7. That gives me a 9 in here, which gives me an 8 in here, which gives me a 9 in here, which gives me a 7 in here, and an 8 in the 15 cage. That forces this to be a 2 next to the 7. That is a 3. Right, that's better. These 2 cells should add up to 11, and they do. That 3 gives me the 3 and the 8. I have a 1 in one of 2 cells because of this one. Then just, actually I could just write in whatever this is. That is not a 4, not a 2, an 8. And these 3 cells need to add up to 12, and it's 1 plus an 11, whatever it is that's left, 5 and 6 again. Right. Where do we go from here? We still haven't really made that much progress. All right, hang on. Remember I did say that the 1 is either in the 8 cage or the 7 cage. It's not in the 8 cage because 1 and 7 are no longer available. 1 and 6 are though. So that's the only place for it. This is now no longer 1, 7 or 2, 6. That's 3, 5. 3s are now lining up. These are not 3s. That's the 3. These 2 cells are now 4 and 9. Not resolved. That's fine. The 20 cage without an 8. I'm wondering if this is now forced. Almost. Not quite. 4, 7, and 9 looks pretty good. And actually the fact that this 3, 5 is gone. So what do I have left? I've got 1, 2, 6 outside if it's 4, 7, 9. If I don't use the 9, 6 and 7 would be 13. That's too small. So the 9 is definitely inside here. Then I need something that adds up to 11. And 2, 9 is not available. 3, 8 is not available. 5, 6 is not available. It is in fact 4, 7, 9. That gives me 1, 2, 6. Can I do any tidying up here? Surely I can. I mean, I can see that the 9s are lining up. So there's a 9 in here specifically. That's not brilliant. Yeah, not really seeing it. And the 2s are not lining up. The 3s are not. I think I'm going to move on and see what else have I left. I should be thinking about. Yeah, how about Sudoku, Sleuth? Let's do that, surely. And that's 6. I mean, with the 4, 5, 6, that's 1. That's 6. These 2 cells are surely known. They are 3, 9. 3 inside a 20 cage would leave me with 17, which would be 8 and 9, but it's not a 9. That's a 9. That's a 3. That gives me a 9 here and a 4-7 pair. And the 7s also now line up. They're down here. Okay. This is 11. It's not 2-9. It's not 4-7, and it's not 5-6. It is, in fact, 3-8. That would be 8. That would be 3. I just think this 2-9, 3-8 is good. 4-7 and 5-6 are not available. That's correct. Then I need surely a bunch of things in here. Can I do better? 1 and 7. So the 1 and 7 are actually lining up as such. And then these two cells are 2 and 8. 2 and 5. 2 and 5 are looking across to give me a 6. Now to complete the row, I need a 1, which can only be in here because of these ones, a 2 or 5 inside the 16 cage. I'm leaning towards the 5, but let me just think this through. So it's 2, 5, 7 with a definite 7. So this is going to be a 4, 5, 6 cage. If it's with a 7, that leaves me a remainder of 9, and 6 and 3 doesn't work. It would have to be 4 and 5, and clearly 2 doesn't work with another 7. In fact, that was, I think, the example I was showing earlier, that it has to be unique. So this is 5, 7, and therefore this is a 4. This is not 4, this is 5, 6. In fact, that 7 gives me 5, 7, no, excuse me, 6, 5, and 7. The 7s are all kind of done now. That's a 7. We'll come back to this. Right, what do we have in here? Can I resolve any of it, or do I need to sort of go back up here? What about these two cells? I haven't really tried to pencil mark or write any of them. So this is 6 and 8, and that 8 gives me an order. That's 8, that's 6. This is not 6, that's not 6, that is a 6. That's useful. I need a 4 and 5. I don't think they're, yeah, they are resolved. 4, 7 gives me 5, gives me 4. The 5 gives me 2, gives me 5. The 1, 7, remember now that the 1, 2 are lining up. That's a 7, that's a 1. All useful stuff. We may as well just carry on. What do I need in here? I need a 2, which is one of 2 cells. Not that you, no, it's not. 2, 3. That's a 2. The 3s, let's not lose sight of them again. Yeah, 3, 4. Looks like it's one of 2 cells. 5 is available. 6 is kind of done. Yep, done. 7, 8. 8. That's 8. That's 4. That's 9. That's not 9. That's a 9. Right. We know what this digit is. We can just write it in. It's a 5, I'm going to say. 5 I can type. And in fact, 5 and 6 gives me 1, 2, 4, 2, 1, 3, 2, 5, 3, not 5 or 1, 6, 5. The 4, 7 and the 7, 9. No, the 9 is done. That's 7, that's 9. 4 and 7. Right, just a couple of things to tidy up and we're done really. 4, 5, 6. And if I've not made any mistakes, 8 for the... Oh, hang on. Yeah. Excuse me. 9 and 4. Right. Kind of anticlimactic there for a second. Lovely puzzle, Tobias. And no, it was unique. There wasn't a bit of irony there at the end to keep us guessing with 2 simultaneous solutions. Hope that you enjoyed the puzzle and the video. I think the break-in was pretty smooth, and then I just somehow struggled with simple maths. We won't refer to that again. And I think that was probably it. There was a bunch of Sudoku that could have been a bit quicker. Hope to see you back for the next video. Bye-bye for now.